And now we're just sort of going to make a list of everything we could do in derivatives. Let's undo it and think about what it would be. So we've already done the first one. And we saw the second one in an example as one that I said you're going to forget this one because it was hard to see that, oh yeah, 1 over x was the derivative of natural log. So you spent some time in derivatives memorizing in one way, but you actually have to spend some extra time memorizing on the way back because your brain doesn't necessarily work that easy. Just because you can go one way, it doesn't say, oh, I'll undo that for you. No problem. And this is very similar to the one we did before. When we did it before, we talked about this property that if you have a constant, you could bring it out in front. So that 12 inside that's multiplied by 1 over x, you could bring that out, and sometimes bringing that out helps you see, oh, do I have it? Okay. A small change that I'm going to add to your notes here, okay? I'm going to get you to put absolute value bars around that x. Sometimes it doesn't matter, but if you think about your natural log graph and you think about your 1 over x graph, oh, and I had another one here. This is your graph of 1 over x, and this is your graph of the natural logarithm. And all that graphing we did in grade 12 is actually really quite helpful for us to understand what's happening. The interesting thing about working backwards from 1 over x is the domain of 1 over x is everything except x can't be 0. So you're allowed to plug in negative values here, like -3 and -5. But when you get your answer as the natural log, well, the natural log, its domain is just positive values. So if you had a -3 here, and you just wrote it's equal to natural log of -3, you have a problem. Because -3 was in the domain of 1 over x, but not in the domain of the natural log. So for the most part, you'll see in a lot of calculus, it's just, oh, the derivative of 1 over x is natural log of x. We won't worry about absolute values because they're messy, kind of, and awkward to work with. But in reality, we should have those absolute value bars there to make it work. And I'll just talk about the e to the x one here. You know the derivative of e to the x is e to the x. So working backwards, it will still stay the same. But if you did have a number in there, you would have a chain rule where you had to multiply. So how do you undo that? You sort of think, well, since there's going to be a chain rule where I have to multiply, I'm going to have to divide to cancel that up. So the derivative of e to the x stays the same, but since there would be a chain rule where you multiply, here we're going to have to divide. And of course, for all indefinite integrals, you have to write plus C. My general rule on quizzes and tests for integration is I give you one pass. If you forget a plus C once, I don't even deduct any marks. Just make a note, you forgot it once. Forget it the second time, then it's a full mark deduction on that quiz or test. And I only take it off once. So if you're like, I'm okay to lose that mark, I'm just not going to write it at all, you could, don't recommend that. But it is super easy to forget, so you're allowed up to 1 mistake, 2 mistakes, and you'll lose a mark. Boy, try this one on your own with a whole bunch of rules. And check how you did. For sine and cos, the negatives get flipped from how they were before. The derivative of sine was cos. The derivative of cos is negative sine. Now the integral of sine is negative cos, and the integral of cos is just sine. And so your negative, again, I really find with sine and cos, if you try to memorize where that negative's going to go in all four, you're going to make mistakes. If you can remember one and remember it well, you probably can work your way through the other ones. So again, I don't know if you remember, but what I had suggested was, if you think about a graph, if you think about a graph of cos or the graph of sine, and you think about the tangents. There's the tangent at 0 for sine. Here's the tangent at 0 for cos, and then right after, the tangents start to go negative. I find thinking about the graph an easy way to remember that the derivative of sine is positive cos, and the derivative of cos, as those slopes go negative right away, is negative sine. Alice puts up her hand just as I explain it. I'm like, did I screw that up? Because it's so easy to get them mixed up. I'm like, Here I told you the best way, like, actually it's in this chair, it shouldn't be. No. It's okay. It's just so now, if you're working backwards, can you see that going from cos back to sine is going to be positive? And going from sine back to cos, since there was a negative there already, there would still need to be a negative. That one's going to be negative. I still have nightmares the first time I printed these notes. I printed it wrong. It's like, first of all, I say, this is really easy to mix up, and your notes are completely wrong. Good luck for the rest of your life. And then here as well, just to add some thinking, I said if we added a k, any number inside, you'd have a chain rule. If you were doing the derivative with a chain rule, for example, if I added the k inside of there, then the derivative would still be cos, but then you would have to do the chain rule and multiply by k. So undoing that in an integral would be dividing by k. Well, the IBs just wrote their integration test a couple of days ago, and Ian wrote to me on the back of his integration test a little joke. My mother's sister is named Integral. I call her antiderivative. Okay. So, find the indefinite integral of sine 5x. That's funny, isn't it? That's hilarious. I quite enjoyed that. So we're going to work backwards from sine. We're going to get cos. Again, we're going to think of our graphs. If I was going from cos to sine, I'd have a negative. So going backwards from sine to cos, I'm going to have a negative. And there would be a chain rule, so I'm going to need to divide by 5 plus c. You think Ian was planning, like, before a test, he's like searching up good puns?
I think he came up with that. I think I helped him out.
That is very, very enjoyable. All right, try this one on your own. Integral of x squared, you wouldn't have to write this down. Equals x cubed over 3. E to the x would still be e to the x. And working backwards from cos is sine. The derivative of sine to cos is positive. So this, we will keep it negative here. I'm simplifying this.